Hello and welcome to the lesson video for lesson 6.3, Conditions for Parallelograms. Just to kind of compare this lesson to your previous lesson, in the previous lesson we looked at what parallelograms were and their different properties. If you knew that something was a parallelogram, what could you conclude about that figure? But in this lesson, we are going to be looking at quadrilaterals with given characteristics and concluding that they are in fact parallelograms. And we will be doing a little bit of proving or verifying, if not a formal proof, that quadrilaterals are parallelograms based on given characteristics. And so that's what our objective is. As always, make sure you have done all of the vocab in your vocab notebook and in the note packet before continuing to watch this video. As we get into our vocabulary in the notes, there's a couple things I want to point out. As you look at the vocabulary for the conditions for parallelograms found in your note packet, it looks a lot like this. Notice this notation, arrow parallelogram. What they're doing in this is using that arrow notation to show you the conclusion of that statement. So whenever I show the forms in this video, what you would write right before this is that shorthand notation that you would use in a proof. It's the part that will be in parentheses, and I'll try and again point that out when we get to that point. All right, you should take a look at this warm-up. For some reason, this answer already popped up, so you really only have the remaining 4 left to do. But do these problems in your warm-up, and then we'll check our answers. Pause the video if you need more time. All right, if you're ready, we'll take a look at our answers. Okay, the reason or justification for this, that QR is congruent to QR, is the reflexive property. Now this picture goes with number 2. The reason that L is parallel to M is the converse of the alternate interior angles theorem. All right, and evaluating each of these, when x is 12 and y is 8.5, number 3 you get 31. Number 4 you should get 183, and number 5 you should get 73 degrees. All right, let's go ahead and take a look at the conditions for parallelograms lesson. You've learned to identify the properties of parallelogram. Now you will be given the properties of a quadrilateral, and we'll have to tell if the quadrilateral is a parallelogram. To do this, we can use the definition of a parallelogram or the following conditions. And here are the conditions listed for you. Here's the first 3. Okay. I'm not going to bother reading every single one of these. You hopefully have these already written, but the part that comes before arrow parallelogram in your note packet would be this. A quadrilateral with a pair of opposite sides that are parallel and congruent makes it a parallelogram. So if you're given a quadrilateral with a pair of opposite sides that are both parallel and congruent, just one pair, like this, then it's a parallelogram. Also, if our quadrilateral has both pairs of opposite sides that are congruent, it has to be a parallelogram. And if a quadrilateral has both pairs of opposite angles congruent, it's also a parallelogram. We can conclude that. And then we have 2 more. Here, if our quadrilateral has an angle that is supplementary to both consecutive angles, then it's a parallelogram. Quadrilateral with angles supplementary to consecutive angles means it's a parallelogram. Also, if we have a quadrilateral where the diagonals bisect each other, then it's a parallelogram. So we have those conditions. Let me recap those for you briefly. If one pair of opposite sides are parallel and congruent, it's a parallelogram. If both pairs of opposite sides are congruent, it's a parallelogram. Or if both pairs of opposite angles are congruent, it's a parallelogram. Or if we have one angle supplementary to both consecutive angles, it's a parallelogram. And lastly, if our diagonals bisect each other, then it is also a parallelogram. So let's work through some examples. First, example 1a. We are given this quadrilateral. You are not told that it is a parallelogram. We want to verify that it is when a is 3 and b is 9. So our first step is to find jk and lm. We are given jk is 5a minus 11. We can substitute 3 in for a, and we get that jk is 34. But I can do the same thing for the same reasons on lm. We're given 10a plus 4 We substitute in 3 for a, and we also get 34. So we can conclude that jk and lm are congruent because they have the same measurement. Now we want to look at kl and jm. We're going to start with the given and substitute and simplify. KL is 5b plus 6. If I substitute the given value of 9 in for b, we get that KL is 51. But if I do the same thing for JM, 8b minus 21 becomes 8 times 9 minus 21, which is also 51. Since JK and LM are equal, and KL and JM are equal, JKLM is a parallelogram by theorem 632. We have both pairs of opposite sides congruent. In example 1b, notice we are given 3 of the angle measures. If you look back through the theorems, there's only one theorem that refers to 3 and only 3 angle measures. Since I have 2 different values here for x and y, they give me those values here. X is 10, y is 6.5. I want to show this is a parallelogram using the theorem that states if a quadrilateral has one angle, which is supplementary to both consecutive angles, then it's a parallelogram. So this is what we're going to show first. We're going to show the measure of angle Q and evaluate it when y is 6.5. Q is 46 degrees. We're going to find the measure of angle S when y is 6.5, and we get 46 degrees. So Q and S are both 46 degree angles. Now I want to find the measure of angle R when x is 10. If I plug in 10 for x, R is 134 degrees. Well, if I took 134 and added it to 46, I would get 180. Since they're both 46, I can say that R is supplementary to both Q and S, so PQRS is a parallelogram because one angle is supplementary to both its consecutive angles. On 1C, notice we are given 2 consecutive angles here, and we're given opposite sides here. So here's what we're supposed to do, is show that PQRS is a parallelogram for A equaling 2.4 and B equaling 9. Since we are given this, PQ and RS both equal 16.8. Whenever I plug in 2.4 for both of these, 7 times 2.4 is 16.8. 2 times 2.4 plus 12 is also 16.8. So I have congruent sides QP and RS. These angle measurements are going to help me state something else. If I plug in 9 for B in both situations, I get 74 degrees for Q and 106 degrees for Q. You should notice that means Q and R are supplementary. Now, this is not enough to state it's a parallelogram on its own, but if you'll remember, if I have 2 lines or segments cut by a transversal in such a way that same side interior angles are supplementary, then the lines have to be parallel. So P, Q, and RS are also parallel. So what we've shown here is that P, Q, and RS are parallel and congruent. So one pair of opposite sides are parallel and congruent. That means it's a parallelogram. All right, in example 2a, we're going to be justifying our answers to determine if these are quadrilateral or are parallelograms or not. So we have one angle supplementary to both angles. 107 plus 73 is 180. So you should write something like this. Yes, the 73 degree angle is supplementary to both its corresponding angles. The quadrilateral is a parallelogram. Determine if this could be a parallelogram or not from the given information. No, we don't have enough information. We have one pair of congruent opposite angles, but that's not enough. So this is not a parallelogram. In this example, you notice this looks a little bit different. We have a parallelogram, or what we're hoping to be a parallelogram. It's quadrilateral, that's all we know for sure, but it is divided into 2 triangles. In this triangle, 2 angles are congruent to these 2 angles. Because what we know about triangles, the third pair of angles would also be congruent. Now, as we look at it as a quadrilateral, we have opposite angles here and here that are congruent. And if I said these 2 angles are congruent and these two angles are congruent, then their sums must be congruent. That means the other pair of opposite angles in the quadrilateral are congruent. So yes, it's a parallelogram because both pairs of opposite angles are congruent. Let me recap that. The diagonal of the quadrilateral forms two triangles. Two angles of one triangle are congruent to two angles of another triangle, so the third pair of angles are congruent by the third angles theorem. So both pairs of opposite angles of the quadrilateral are congruent when you combine these. So by this theorem, the quadrilateral is a parallelogram. On this one, notice that these sides are congruent and these sides are congruent. So I have two pairs of sides congruent, but notice these are not opposite sides, nor are these. These are consecutive sides. So no, two pairs of consecutive sides are congruent, not opposite. None of the conditions are met for parallelograms. All right, here's another helpful hint. To say that a quadrilateral is a parallelogram by definition, you must show that both pairs of opposite sides are parallel. So in example 3a, we're going to show that quadrilateral JKLM is a parallelogram using the definition. And let me remind you of what that states. You must show both pairs of opposite sides are parallel. So if we're going to put this in the coordinate plane, parallel lines are shown by lines having the same slopes. So we're first going to find the slopes of both pairs of opposite sides before I even put this on the graph. You know opposite sides are opposite because they don't share an endpoint. So JK would have to be opposite LM. So the slope of JK is negative 5/3. The slope of LM is negative 5/3. They have the same slope, so JK and LM are parallel. But if I look at JM and KL, those would be the other two sides. Slope of JM is 3/4. The slope of KL is also 3/4. Since they have the same slope, they are parallel. Since both pairs of opposite sides are parallel, JKLM is a parallelogram by definition. Now, I've placed the graph on your notes for you. You're welcome to graph that and use rise over run to show the slopes are the same rather than using the slope formula. Okay, on 3b, we're going to do a very similar thing, but we want to use theorem 631. So let me remind you of what theorem 631 states. Theorem 631 states that if a quadrilateral with a pair of opposite sides parallel and congruent, then it's a parallelogram. So what I want to show on this next example is that one pair of opposite sides are both parallel and congruent. To show they are parallel, we will use the slopes of each line, showing that they're the same. And to show they are congruent, I will use the distance formula. Finding the slope and lengths of one pair of opposite sides is what we're going to do first. So let's just pick a side. AB has a slope of negative 1/4. The side opposite AB would not have A or B as an endpoint, so I use the other two endpoints, C and D. So I'm looking for the slope of CD. It is also negative 1/4. Since these have the same slopes, they are parallel segments. Then I want to find the length of that same segment using the distance formula. The distance between A and B is the square root of 17. I don't need to worry about rewriting that. That is simplest radical form. If I find the distance between C and D, I also get the square root of 17. A, B, and CD have the same slope, so they're parallel. And since they have the same length, they are congruent. So by theorem 631, ABCD is a parallelogram. You've learned several ways to determine whether a quadrilateral is a parallelogram. You can use the given information about a figure to decide which condition is best to apply. Here are the conditions for parallelograms. What I want you to do to finish out your notes is to fill in the graphic organizer, filling in one of these conditions in each of the bubbles, and then you'll be ready to start the assignment when class resumes on Monday.